Hi Calculus 1 students. So this is the last problem of section 3.4.2, higher derivatives. Now remember, like you have two YouTube videos to watch, like one was presented before, was about patterns, and this one is about kinematics. That's like the two subsection of higher derivatives. So here it is. The position of a particle in meters is given by this position function. So t over t squared plus 1, where t is time in second. And we are asked, when is the particle speeding up? Okay, so first of all, we need to understand the question. Okay, so when is the particle speeding up? Okay, and this is a little bit hard for a mathematician because it does involve a concept in physics. It does involve a little bit the angle between two vectors, but don't worry about it. Speeding up pretty much means that the velocity and the acceleration are both have the same sign, okay? Are both pointing in the same direction, if that makes sense. Okay, so this is what we need. We want to know whenever v of t and a of t have the same sign. So this means that we need to actually compute these two quantities. We need to compute both v of t and a of t. And then we need to compare their signs. So we're going to rely on a sine chart to do this. We presented the concept whenever we did the first example of this type in class. Okay? So number one is really simple. Compute the velocity, compute the acceleration. So the velocity, as we saw, is the derivative of the position function. Okay? And in order to do this, like you have the choice between the product rule or the quotient rule here. And I think I'm gonna go with the quotient rule because the quotient rule does have an advantage over the product rule, is that it produces you a fraction, like just one fraction. And it's nice whenever you want to simplify the derivative in order to do stuff with it. So we're going to use the quotient rule directly, and you know how it works. So derivative of the top multiplied by the bottom minus the top times the derivative of the bottom divided by the bottom squared. Okay. Here, performing the second derivative on that would be a huge mistake. Okay. Always simplify your first derivative before you take a second. Typically, like as you move on to study stuff at university, you will quickly realize that the more derivatives you take, the more tedious it gets. So you always want to simplify your first derivative before even thinking about taking the second. And simplifying it will give you something rather simple. It will give you 1 minus t squared because these two terms will pair up. Okay, so I'm just going to underline them in red just for you to see that they end up being like terms. And then divided by t squared plus 1. Okay, I could already find the zeros of that function if we wanted to, but we're going to do that after, when we deal with the acceleration. So let's go and take the acceleration. The acceleration, remember, it is the derivative of the velocity. In other words, the second derivative of the position. So let's go ahead and use the quotient rule again. So derivative of the top, which will be negative 2t, times the bottom, and here I feel that I forgot a square. There you go. All right, and you will see this complicates the derivative a little bit, but not by much, okay? It's still something that you can manage. Now, minus the derivative of the bottom is an outside-inside rule. Okay, so a chain rule in other words. So be careful about that. So you're going to have twice the inside, so t squared plus 1, times the derivative of the inside, which is 2t. And that's going to be multiplied by the top. Okay, it's not really a mistake, but I will actually erase this because I want you to get used of writing the top first. So the top is 1 minus t squared. And now you're doing your outside-inside rule. And then all of this is getting divided by t squared plus 1 to the power of 4. Okay. I can see now that I'm writing this, I can see that the quotient rule was probably not the best choice. It might have been better to actually write the product rule by bringing this on the top. Okay? But now that I've done it, let's continue with what we have. The only trouble is going to be on simplifying this. It's not going to be very hard because look, you have a common factor of 2t. Now I'm going to take advantage of the fact that I have a negative here to also factor the negative there. Okay? So first off, we're going to factor out the negative of 2t. So negative 2t. And then we also have a common factor that I'm going to underline in purple. That's the one we would have avoided if we did the product rule instead of the quotient rule. But we can easily catch up on that small mistake. It's not even a mistake. It's a mistake of efficiency, right? And now we write the big bracket. So whatever is left of that. In this term, the only thing left is t squared plus 1. That's the first term. So in other words, like 1 exponent of this. That's what's left. Now, be careful. There's no more minus. It was part of the factoring. So this turns into a plus. Okay, I'm going to keep the color code just for you to keep your eye on the ball. Now, what's left out of this? The 2 is left. Okay, so this green 2 that I'm going to keep the color code on, multiplied with the 1 minus t squared. Now, all of this is divided by t squared plus 1 to the power of 4. And now it's rather simple to simplify. Well, I mean, it's not that simple, but simplifying this is okay, right? We can manage. So we're going to have negative 2t. Now we're going to use the rules of exponents to simplify that down. We have this to the power of 1. So overall, we're going to have, let's actually keep the fraction. We're going to have t squared plus 1 to the power of 3, okay, instead of 4. And now we're simplifying that. What is left? So 1 plus 2 is 3. And I'm putting it first because, as you can see, the resulting coefficient of t squared is going to be negative. You're going to have t squared minus 2t squared. So minus 3t squared. Okay. Now, for what follows, it's very important to have both the velocity and the acceleration both written here and fully simplified. Okay, so for the velocity, we will have, actually, it's even useful to factor out everything. So, okay, I need more space. I will need like a bigger box. Okay, so for the velocity, we're just gonna factor the top here, which is a difference of squares. It's gonna be like 1 minus t, 1 plus t, divided by t squared plus 1 squared. As for the acceleration, we're gonna have, shoot, I don't have enough space still. What could I do? Oh, I have an idea. I'll just erase everything that's here. Now I have the velocity, so I'll erase this, I'm safe. And let's write them here right at the beginning, okay? So we found out that the velocity is 1 minus t, 1 plus t divided by t squared plus 1 squared. And we found also that the acceleration, now we're going to factor this as a difference of square as well. It's going to look weird, but bear with me. It's going to be the square root of 3 minus t times the square root of 3 plus t divided by t squared plus 1 cubed. Okay, now here's the time to do our sine chart. So what we want to do is to first solve v of t equals to 0. And that will happen when t is equal to 1 or t is equal to negative 1. We obviously do the same for a of t is equal to 0. And here we're going to have 3 values. We're going to have t equals 0, t equals negative root 3, and t equals positive root 3. All right, now here comes the sine chart. So, all right, I probably should have said in the problem that t is greater than 0. That would actually have helped. So yeah, let's actually say it, okay? Let's actually say, and this will be the case most of the time, that t will be greater or equal. Well, it will never be exact. It will be it will be exactly equal to 0 only when we're starting the experiment. But here we go. Okay, so what does it mean? It means that this t equals 1, negative 1 is not in the interval, and t equals negative 1/3, negative square root of 3 is also not in the interval. So in 0 to infinity, and same thing here, is not in 0 to infinity. Now here's what the sine chart looks like. So what you do is very, very simple. You will put, well, first here you put 0, okay? So this corresponds to the 0 position. And you're going to put in order the points at which the velocity is changing. So 1 in this case, and the point at which the acceleration is changing. So in this case, it's going to be the square root of 3. And now you're going to look at the factors of v of t. What are they? We have these two things. So between 0 and 1, so note that this and this will always be positive. Okay, so these two factors are always positive. So, but when t is between 0 and 1, this is positive as well. Okay, so it means that the overall factor is positive. Okay, so we know that the velocity is positive there. Now, after 1, what's going to happen? This and this is positive, so we're okay there. But this will now become negative, making the overall velocity negative. So it will be negative forever after. We're now looking at the acceleration, and we do the exact same analysis. So we just need to be slightly more careful because there's a negative sign right here, okay? So be careful about that negative sign. So one thing that you could do is actually distribute it in the factors. But let's not do that. Let's if we are careful enough, we should be fine. This, notice that it's always positive no matter what. This will always be positive because t is at least 0. So, and this will always be, well, positive, but because of the negative here, it will always be negative. So actually, let's go ahead and distribute the negative in just to avoid making mistakes. So a of t will be equal to 2t. And then we use the negative to swap these two things. So t minus square root of 3. Then we have square root of 3 plus t. Okay, so this part doesn't change. Divided by t squared plus 1 to the power of 3. So now you can see really well what's happening. Everything is positive except this. Well, this will be negative before square root of 3. So our acceleration will be negative here and here, but will turn back positive here. All right, then okay, that's all good. So then what's happening? In this interval, the velocity and the acceleration don't have the same sign. So this means that our particle is slowing down. In this case, they have the same sign, so it means that our particle is speeding up. And finally here, the particle is also slowing down. So in other words, you get the answer from the chart. So the particle is speeding up, for the interval of time in which t is between 1 and square root of 3. And I won't put the units of measurement because I consider this as being like a small distraction. There you go. This is your final answer. So sorry for the time of the video. I just realized that it was a little bit long with all of this like analysis, but there you are. Hopefully this helped, and see you in the next video or in the next class.